Hello everyone, welcome back to my channel. From today, I am going to start first term syllabus of class 12th physics. According to revised syllabus, pattern of examination is changed. Your whole first term exam consists of only MCQ types, and MCQ may be of different types like assertion reasoning, case study based question and other types of multiple choice questions. So I will cover each type of MCQs chapter wise. And let us start it with chapter 1 electric charges and field. But before watching this video, you must go through one short revision of this first chapter electric charges and fields, which is available on my channel, and link is given in the description box so that it becomes easy to understand this video. In this video, I will first discuss case study based type questions, and there may be 2 or 3 parts of MCQs of each chapter. Okay, so let us start with chapter 1. Chapter 1 and chapter 2 comes under unit electrostatics and second unit current electricity. Both these units together consist of 17 marks. So out of 17 marks, first unit may be of 9 or 10 marks, and out of these 10 marks, first chapter may be of 5 or 6 marks. So there may be chance to come one case study based question from this chapter 1 electric charges and field. In this chapter, there are many important topics like Coulomb's law, right? What is Coulomb's law? You already know. So that's why you, before watching this video, you must go through one short revision of this chapter so that it becomes clear and easy to understand case study based question based on these topics. So first important topic is Coulomb's law, then superposition principle. After this, electric field due to a point charge. All these topics are important. What is electric dipole? Electric field due to a dipole, both axial and equatorial position. Then torque on a dipole in a uniform electric field. What happens when dipole is placed in a uniform electric field? After that, electric flux. And then last topic, Gauss theorem. And there are two important applications of Gauss theorem. One is field due to infinitely long straight wire, another one is field due to uniformly charged infinite plane sheet. So all these topics are important, and I will discuss MCQ based on all these topics. And first MCQ, I am going to discuss about case study based question, and first case study based question is based on Coulomb's law. Let us start that one. Okay, now first one is Coulomb's law. You already studied about Coulomb's law, but still you must go through all these lines so that it becomes clear what questions are given based on this Coulomb's law, right? So let us start reading. This law is a quantitative statement of about the force between 2 point charges. Actually, this law gives force between 2 point charges. Suppose there is one charge Q1, another one is charge Q2, and this gives force between, quantitative measurement of force between these two charges. Now, what do you mean by this point charge? It's written here, when the linear size of charged bodies are much smaller than distance between them. If the size of these two charges are so small as compared to distance between these two charges, right? In that case, you can say these two charges are point charges. So, after retiring from his active services as military engineer in 1776, Coulomb, a French physicist, discovered a torsion balance to measure a small quantity of force and used it for determination of forces of attraction or repulsion between small charged spheres, right? He thus arrived in 1785 at the inverse square law relation, now known as Coulomb's law. According to this law, the force between 2 point charges varied inversely with the square of distance between the two charges. Force is inversely proportional to square of distance between the two charges and also directly proportional to product of magnitude of charges. It means force is directly proportional to Q1 and Q2, right? Okay, and acted along the line joining the two charges. The actually force is a vector quantity. So what is direction of these forces? Force always acts along the line joining the two charges, right? So when you combine these two, Coulomb's law becomes what? F equal to Q1 Q2 by R square, directly proportional to product of the two charges and inversely proportional to square of distance between them. And the proportionality constant you write here K. And what is K? Constant K equal to 1 by 4 pi epsilon naught. Epsilon naught is permittivity of free space and its value you know. And what is the value of K? When the two charged bodies are kept in air, for air or vacuum or free space, K is equal to what? 9 into 10 to the power 9. So this is about this paragraph, Coulomb's law. Now you know what is Coulomb's law, what is the formula for that one, what is the relation between force, charge, distance between the two charges. So it's written, everything is given here, right? Force exerted by first charge on second one is equal and opposite to force exerted by second body on first one. If both are positive charges, so first body exerts force on second body in this direction. This is the line joining the two charges, so force is acting in this direction. And force exerted by second body on first one is F1 in this direction. Why these two directions? Because both are of same nature, positive charges. So both forces are repulsive in nature, right? And if one force is positive and another one is negative, so both are attractive in nature. Like charges repel each other, unlike charges attract each other. And the magnitude of these two forces, first body acting on second body and second body acting on first body, is given by magnitude is same. F1 equal to F2 equal to K Q1 Q2 by R square, right? So this is about Coulomb's law. Now let us start to solve question number 1. What is question number 1? Here it's given that identify the wrong statement in the following. Coulomb's law correctly describes the electric force that. Some statements are written here about Coulomb's law. You have to find the wrong statement. Okay. So you know Coulomb's law, everything about Coulomb's law. Now let us read all these options one by one. First one is Coulomb's law. It binds the electrons of an atom to its nucleus. Yes, electrons has some charge and it binds the electrons of an atom to its nucleus. This option is correct according to Coulomb's law. Second one is it binds the protons and neutrons in the nucleus of an atom. No, neutrons is what? Neutron has no charge. Right now, neutron has no charge. It is neutral. And Coulomb's law is only valid for point charges, not for neutral charges. Right now, neutrons has no charge. It is neutral. So Coulomb's law is not valid. This statement is wrong for neutrons. It binds. There are two other options. Must read it also. Binds atoms together to form molecules. Yes, it's correct. It binds atoms and molecules to form solids. Yes, this statement is also correct. So correct option is which one? B is correct option. This statement is wrong according to Coulomb's law. And other first three options A, B, C and D, all three options are correct. So in this way you solve questions, right? Now second question. Now second one is two charges 3 into 10 to the power minus 5 Coulomb and 5 into 10 to the power 4 Coulomb are placed at a distance 10 centimeter from each other. There are two charges Q1 and Q2 and both are kept at a distance of 10 centimeter. Now you have to first convert this 10 centimeter into meter. It becomes 0.1 meter. So distance between these two charges are given 0.1 meter. Value of the two charges are also given 3 into 10 to the power minus 5 Coulomb and another charge Q2 is 5 into 10 to the power 4 Coulomb. Right? Now you have to find the value of electrostatic force between them. It's very easy. Just according to Coulomb's law, what is the formula for force? F equal to K Q1 Q2 by R square. Now what is the value of K? 9 into 10 to the power 9 into first charge is 3 into 10 to the power minus 5 and second one is 5 into 10 to the power 4 divided by distance is what? 0.1. So put 0.1 meter whole square. So after calculating this one, first pause the video and try to calculate it, right? Okay, hope we have calculated. Now after calculating this one, you get first option, that is 13.5 into 10 to the power 11 Newton. After solving this one, you get this one. So correct option is which one? A. A is correct option. Force between the two charges becomes 13.5 into 10 to the power 11 Newton. In this way you calculate this question, right? Now next question number 3. Now question number 3. Third one is, each of 2-point charges is doubled and their distance is halved. Okay, suppose Coulomb's law, according to Coulomb's law, force is what? F equal to Q1 Q2 K Q1 Q2 by R square. Now each of the 2-point charges is doubled. It means Q1 becomes twice Q1 and Q2 becomes twice Q2, and their distance is half. The distance, original distance is R, now it becomes R by 2, right? Force of interaction becomes N times, where N is, now force increases. Now how much time it increases? Now you have to calculate new force, F dash. So this time first charge is 2Q1, second charge is 2Q2, and distance is R by 2 whole square. Now you solve this one. So K 2 to 4, 4 Q1 Q2 by R square by 4. This 4 goes in the denominator, it becomes 16 K Q1 Q2 by R square. New force F dash is this one, and this K Q1 Q2 by R square, this is what? Original force F. So you can write F dash equal to 16 F. So new force is 16 times this old force. So try to pause the video and try to solve this question, okay? And so according to this one, after solving, N becomes what? 16. So correct option is D1. First try to solve by yourself by pausing the video, okay? Then it becomes easy to solve, okay? So in this way you solve question number 3, and how much time? It becomes 16 times. So you have to calculate new force and compare it with old force. How much time? 16 times. In this way we calculate this question, okay? Now after this, question number 4. Question number 4 is, the minimum value of force acting between 2-point charges placed 1 meter apart from one another. There are 2-point charges Q1 and Q2, and distance between these two charges is what? 1 meter. Now you have to calculate minimum value of force. Minimum force is only possible, you know, charge of electron is minimum. Other charges may be multiple of that minimum value of charge. So here it's very easy that minimum force means charge is what? Electron. So first charge is also electron, second charge is also electron, because you have to calculate minimum force, and minimum force is only possible if charge is less, and minimum charge is only for electrons. So these two charges are what type? Both are electron, and distance between these two charges is 1 meter. So force is what? K Q1 Q2 by R square. K Q1 is also E, Q2 is also E. So E into E by R is what? 1 meter square. So this becomes K E square. Right now, so which one is correct option? F equal to K E square. Option number first one is correct, A. In this way you solve this question. One key point is given here, minimum value. So from this minimum value you easily understood that the charge is electron, right? In this way you solve question number 4. Now after this, one more question, question number 5. What is this? Okay, this question number 5 is, A and B are two identical spherical charged bodies which repel each other with force F. There are two identical charge bodies, one is A, another one is B, and both these charge bodies exert force on each other. That force is of repulsive type. It means both have identical body, means both have same charge. Suppose this has charge Q, this second body has also charge Q, and repulsive force means both have same nature, both are positive, right? So this one is given, repel each other with a force. The force between these two charges is F, kept at a finite distance. A third uncharged sphere of same size is brought in contact with sphere B. Another third charge is kept in contact with this B charge. So this third charge is C, and this is kept in contact with this B charge, right? B sphere. Now what happens when two bodies comes in contact with each other? Transfer of charge takes place until it reaches equilibrium position. So if B has Q charge, it means after transferring charge, B has also Q by 2 and C has also Q by 2. Transfer of charge takes place until both reaches equilibrium condition. Both have same charge, right? So C also acquires Q by 2 charge, and after that it is removed. Now C is removed from this position. It is then kept at midpoint of A and B. Now this third charge is kept at this point, A and B. Find the magnitude of force on C. Now you have to calculate force on this C charge due to first sphere A and second sphere B. How you calculate? This C has charge Q by 2. First has charge A sphere has charge Q, B has charge Q by 2 and C has charge Q by 2. Now you have to calculate force on C due to these two charges. So you know force on C due to this A body is what? Both are same type. The force is in this direction, right? Force due to A. And what is the force due to A? What is its magnitude? K, Q1, Q2 by R square. If distance between the two charges is R, now C is kept at midpoint. So this becomes R by 2 and this side BC also becomes R by 2. Now distance between A and C is R by 2. A has charge Q, C has charge Q by 2. So K, first charge Q into Q by 2 by distance is R by 2 whole square. So this FA becomes K Q square by 2 into R square by 4. These two cancel, it becomes, and this 2 goes in numerator, twice K Q square by R square. This is force on C due to A. In the same way, you can calculate force on C due to B. How you calculate this one? Okay. Force on C due to B. K, C has charge Q by 2, right? B has charge Q by 2 and distance is again R by 2 whole square. This becomes K Q square by 4 into R square by 4. This 4 cancel. It becomes K Q square by R square. Now you calculate both these forces, and direction of these forces both are positive. So this force is in this direction, right? So you have calculated A, FA is twice K Q square by R square, right? And this FB is what? K Q square by R square. And original force between A and B is what? F. And this one is what? K Q. Both have same charge, Q square by R square. This one is original force. And force due to A is twice K Q square by R square. So you can easily write this K Q square by R square as F. It means FA is twice F. And FB is what? K Q square by R square. This is F. So FA is 2F, FB is F, and both are in opposite direction. So net force is how much? FA minus FB. FA is greater than FB right now because magnitude of these two charges is greater than this B and C. So FA minus FB, it means 2F minus F. And 2F minus F becomes what? F. So which option is correct out of all these four? C is correct, right? In this way you calculate this question. This one is a little bit lengthy, but still you have to solve step by step. That force between the two charges is given F. Now third uncharged sphere is kept in contact with B. Charge distribution takes place. Now then remove and it is kept at midpoint of A. Then you have to calculate total force on C due to A and B, and after that you get answer F. Option number C is correct, right? So in this way you solve case study based question. Now second case based question is based on electric dipole. Paragraph is, it is based on electric dipole. Now you already know about electric dipole, but still you have to read each line very carefully. Okay. The electric field due to charge configuration with total charge 0 is not 0. But for distances large compared to size of the configuration, its field falls off faster than 1 by r square. The electric, what is written here? If total charge is 0, like dipole. Dipole is what? It is a system of two equal and opposite charges. One is plus q and the one is minus q. And separation distance between these two is r, suppose. They are twice r. Okay. Now net charge is 0, but still there is some electric field and it varies with 1 by r square. It is written here. Typical of the field due to a single charge, right? An electric dipole is simplest example of this fact. Okay. An electric dipole is a pair of equal and opposite charges plus q and minus q separated by some distance. Here it is written 2a. If dipole moment vector P is dipole moment, has magnitude twice qa. This is dipole. So dipole moment is what? P equal to, it is equal to product of the two charges q into distance between the two charges, that is twice a. So dipole moment is twice a q. It is written here, twice qa. And what is direction of dipole moment? It is from minus q to plus q. It is in the direction of dipole axis from minus q to plus q. The electric field of the pair of charges can be found out from Coulomb's law and the superposition principle. You can easily find the electric field due to these two charges. The magnitude and direction of the field, dipole field, depends not only on the distance r but also on the angle between the position vector r and dipole moment p. What is the angle between r and p? Electric field also depends on angle, not only on distance. In some molecules like H2O, water molecule. Water molecule means H is, one H is here right now, okay, and another H is here, and oxygen has a negative charge. This is the model of this. It is given here, water molecule. So oxygen is of negative charge and this hydrogen, center of these two hydrogen is positive charge here. So there is one negative charge and there is one center positive charge, and distance between these two are given. So it must have some dipole moment. Dipole moment is what? If there is a separation between two equal opposite charges, then it must have some dipole moment. So water molecule has also centers of negative charge and positive charge do not coincide. They have separation between positive charge and negative charge, right now? And due to this separation, it has permanent dipole moment. Such molecules are called polar molecules. Those molecules which have permanent dipole moment are called polar molecules. So electric dipole you already studied. Now based on that one and on the basis of this paragraph, some questions are given here. Question number 1. What will be the value of electric field at the center of the electric dipole? First option is 0. Second option is equal to the field due to one charge at center. Third one is twice the electric field due to one charge at center. And third one is half the value of electric field due to one charge at center. Think about it. Which option is correct? Fast. Yes. Which option is correct? Dipole means positive charge and the one is negative charge, and distance between two charges is given twice A. Right now, what will be the electric field at the center of the electric dipole? It means at this point, here distance is A, here also distance is A. Now you have to find total electric field at this center. So what is electric field at this center? Due to this plus Q charge, electric field is in this direction, and due to this minus Q charge, electric field is also in this direction, E1 and E2. So both these electric field are in the same direction. It means electric field is, which option is correct? Yes, C1. Twice the electric field due to one charge at the center. Both has magnitude charge, distance both A. So whatever electric field due to this plus Q charge is same as electric field due to minus Q charge, and both are in the same direction. So it is twice the electric field due to one charge at the center. In this way you calculate this question, right? Now question number 2. If R is distance of a point from the center of a short dipole, this one is dipole plus Q, and here minus Q, and R is distance of a point from the center of a short dipole. This is the center, and R is distance from this dipole. Then the electric field intensity due to this short dipole remains proportional to. Suppose you have to find electric field at this point P, okay, along the axis. So this R is distance from this center, or if you want to find, this is axial position. If you want to find at equatorial position electric field at this point, so this distance from the center is also R. So total electric field at equatorial position or axial position, it is what? Proportional to R square, R cube, R to the power minus 2 and R to the power minus 3. Which option is correct? Yes. Yes. We got the answer. You know, electric field along axial position is what? Twice Kp by R cube. And electric field along equatorial position is what? Kp by R cube. In both cases, it is inversely proportional to R cube. It means which option is correct? Option number D, R to the power minus 3. Okay. In this way, you solve question number 2. Hope it's clear to all of you right now. Now, question number 3. Now, question number 3 is, an electric dipole coincides on z-axis and its midpoint is on the origin of the coordinate system. Suppose this one is z-axis, an electric dipole coincides on this z-axis. This one is minus q, this one is plus q. This one is z-axis, right? And its midpoint is on origin of the coordinate system. This one is midpoint. At this midpoint, its origin. This is the midpoint. So this one is 0, 0, origin of this system. Now, the electric field at an axial point at a distance z from origin is Ez. This is the axial position along the axis. Suppose this one is axial position P. Now, electric field at a distance z from this midpoint, this distance is z, is what? How much? Ez. An electric field at an equatorial position. This one is equatorial position at a distance y from origin. This distance is y from origin, and here electric field is how much? Ey. So electric field along axial position given here is Ez at a distance z from the origin, and electric field along equatorial position is given Ey at a distance y from the origin. Here it's given that this distance z equal to y. Now you have to find ratio of this Ez by Ey is equal to what? So first you find Ez. Ez is what? Electric field along axial position. This is twice Kp by R cube, and distance is what from the center origin? This distance is z. So z cube. Again, electric field along equatorial position is what? Ey. And this is Kp by distance is how much? From the center. This one is y. So y cube. You must know about the equatorial and axial position electric field right now. Along axial position is twice Kp by R cube, and axial equatorial position is Kp by R cube. Here it's given that z equal to y. It means Ez becomes what? Ez becomes twice Kp by, if z equal to y, so you write in place of z, you write y cube. And again, ratio of this E y is what? It is Kp by y cube. So this Kp by y cube, Kp by y cube cancel and the ratio becomes what? 2. So which option is correct? 1, 3, 4 and 2. Yes, D option is correct. Answer is 2. In this way you solve this question. Hope it's clear to all of you. Now, next one is question number 4. It's given that, wait. Yes, question number 4. An electric dipole of dipole moment P is placed in a uniform electric field. This one is electric field, uniform electric field, and a dipole is placed in this electric field minus Q plus Q. And dipole moment is from minus Q to plus Q, P. The maximum torque experienced by the dipole. And now this is electric field A, dipole moment is from minus Q to plus Q, angle between this P and E is theta. So what is the formula for torque? Yes, torque is what? Yes, PE sine theta, or you can write P cross E. Right now, here theta is what? Maximum torque means when theta is how much? If theta is 0, sine 0 is 0, torque becomes minimum. 180 also, torque becomes negative minimum. Right now, torque is maximum when theta is what? 90 degree. Then this tau maximum becomes how much? PE sine 90. And sine 90 is what? 1. So it becomes PE. Which option is correct? Option number A. Maximum torque experienced by the dipole is PE. In this way you solve this question. Now one more last question of this paragraph. The last one is the frequency of oscillation of an electric dipole having dipole moment P and rotational inertia I oscillating in a uniform electric field is given by. You have to find frequency of oscillating electric dipole. You know, when dipole is placed in a uniform electric field, it experiences some torque. That tau is given by PE sine theta. Okay. Now, due to inertia, it tries to opposes the motion. So restoring torque is developed in the dipole, and that restoring torque is in negative direction to this one, applied torque. So it is minus PE sine theta. And when angle is very small, this sine theta tends to theta. So it becomes minus PE theta. This is equation number 1. This one is restoring torque. Now, you know, in case of linear motion, F is ma. So here in case of rotational inertia, rotational motion, force is replaced by tau, m is replaced by moment of inertia, and this is angular, this acceleration is replaced by angular acceleration I alpha. This is angular acceleration. Now from 1 and 2, you compare these two. So I alpha equal to what? Minus PE theta. Right now, equation number 3. Now here you can easily find that alpha, this angular acceleration alpha is directly proportional to theta. Okay, and you know angular acceleration is what? Omega theta. Angular acceleration is angular velocity into displacement theta. So this is angular acceleration. So if you compare these two, okay, na? In place of alpha you write what? Omega theta. Okay, so alpha equal to omega theta, and from here in equation number 3, alpha is what? Minus PE theta by I. So there are two values of alpha. From this equation number 3, you get alpha equal to minus PE theta by, this negative sign shows restoring torque, and you know alpha is omega theta right now, this one. So you compare these two equations, you get this is theta, this one is theta. It means omega square theta. Right now, alpha equal to omega square theta. So this omega square becomes what? P E by I. And from here you can find omega. Omega is what? 2 pi by, yes, okay. Omega is under root P E by I. So after calculating omega, you know omega is 2 pi nu. 2 pi nu. So 2 pi nu equal to under root P E by I. It's very lengthy, but still you tried it, okay. So from this one, angular frequency becomes how much? 1 by 2 pi under root P E by I. In this way you calculate angular frequency. So which option is correct? Which one is correct? Option number, yes, yes, B. 1 by 2 pi under root Pe by I. This option is correct. So little bit difficult, but still you tried this one. You know torque is P sin theta, then restoring torque is minus P sin theta, and you know in rotational motion tau is I alpha. You compare these two equations, you get alpha right now, and after that you know alpha is omega theta, you get the value of omega, okay. And after that one, omega is what? 2 pi nu. So 2 pi nu, you can easily calculate frequency equal to 1 by 2 pi under root P by I. In this way calculate this question. Hope it's clear to all of you. So today I have discussed two study based question. One is based on Coulomb's law and another one is based on electric dipole. Hope you like this case study based question right now. This is part 1 of case study based question. So if you like or want this type of videos, you must write in the comment box. So I will make second part of this case study based question. Up to then students, keep revising and stay tuned with this channel. Thank you.